I am going to start the third part of your lecture, that is force. Come to the point. Today we have to study about the rigid body. What is rigid body? So any material which had no deformation after applying some force at the limitation to the force, there is no deformation, then you say that that body is what? Rigid body, means hard body. For example, there is a rod here. This rod is a rigid body because I am applying some force, but there is no deformation in this body. That's why this body is called as a rigid body. The bench in your class is the best example of a rigid body. Okay, so come to the point. A rigid body, as I mentioned here, it is also called as a rigid object. Rigid object. For example, this is the duster. If I am applying some force on it, I am not able to deform it, to change their shape in this object. It means that this is a rigid body. Definitely, in which deformation is zero, or distance between any 2 points on a rigid body remains constant. For example, if I have taken 2 points in dusters, just for this is I am mentioning here. This is the 1 point and this is the another point. After applying force on it, this point is always fixed. Always distance between these 2 points always remains constant, means that it is a rigid body. So I hope that you are able to understand that what is rigid body. Okay. Now what happened to this type of body, means rigid body, when apply some force? जब हम कोई फोर्स लगाते हैं रिजिड बॉडी पे, तो फिर इसके साथ क्या हो सकता है? So come to the point. When force applied on a rigid body, it can have two kinds of motion. Definitely, अगर हम किसी रिजिड बॉडी पे फोर्स लगाते हैं, तो इसके पास दो तरह का मोशन हो सकता है. आपको मैं बताऊं, देखिए, ध्यान से समझिए. Listen to, be carefully that when I am applying force on this duster is moving in a straight line in the direction of the force applied. Okay, means force जिधर लग रहा है उधर ही डस्टर मूव कर रहा है, और उसी डायरेक्शन में कैसे मूव कर रहा है? लिनियरली. सो there will be linear motion or translational motion. That is the same thing. Translational motion. If we apply some force somewhere like this, and I am applying a force and rotating this, okay, applying force and rotating this, it means it should be have a rotational motion. Means that what happened if we applied force on a rigid body, there will be two things it may be happen, that is the body have a linear motion or translational motion, or it may have rotational motion. You all people will ask, or a question that arises in your mind, that what do you mean by translational motion? Translational motion. Let us assume that this is a body having a lot of points in this body. There is a lot of points in this body. I have mentioned it as P1, P2, P3, P4, so on. If we are applying force, we apply force on this body, and these all particles starts moving in the direction of force, in a straight line, then we say that the body has a motion called linear motion or translational motion. Okay, the points, each and every points of that body should move in a straight, either that the central of gravity or any other points, that all should move on a straight line. Then we say that the body is what? In linear motion or transformational motion. Moving in the direction of applied force, as I mentioned, that is a linear motion or transformational motion. Now come to the point rotational motion. If this type of body here is a disc, I am applying force on this point. On this point, each and every point of this body will start moving in this direction, in a curved path. Okay? In a curved path. That's why it will rotate, start rotating. Start rotating. At the same point, they will start rotating on a circular path. Each and every points of this substance or this body will start moving on a circular path. That's why this motion is called as rotational motion. This motion is called as rotational motion. Okay. Now come to the point moment or turning effect. This is called as moment or turning effect of force. It means that if we apply force and body start turning, that's why this effect of force is called as turning effect, or it is also called as moment, or its another name is also torque. What is torque? That is, what is moment? What is turning effect? Definitely, if a body is pivoted means hinge means fixed. For example, this board is hinged here, so this board is not moving from anywhere because it has been hinged at the 4 point. That's why if the board is hinged at a 1 point, the board will certainly move down. Definitely move down. Same is here. This body is pivoted at a certain point. Let me understand that clearly. Let us assume that there is a body which is hinged, pivot, take at point, pivoted at point P point पे ये pivot किया गया, means fixed किया गया, and after all I am applying some force here. I am applying some force F here. The body will start turning in such a way. Body will start moving in circular way. That's why the product of force and perpendicular distance of force from the point of hinge means pivoted. Hinge, this will be the distance of force from the point of hinge. Let us say that this is a D. It is also called as perpendicular distance because the angle between this distance and force is 90 degree. It's 90 degree. That's why it is called as what? Perpendicular distance. Then it means torque is force into perpendicular distance of force from the point of hinge. If we denote it, it is denoted by tau. It is denoted by tau. Tau. You may say that tau. Tau. Okay? Tau. So force into perpendicular distance D. It is a vector quantity. I am saying that it is a vector quantity. Tau is a vector quantity because it is a cross product of distance and force. Sorry, you may say that distance or displacement. Okay, cross product of distance and force. Okay, so tau it has magnitude and direction. Magnitude and direction. Both. Okay. Since in vector quantity there is a need for calculating the magnitude and also finding the direction. Okay. So we have understood the formula for torque and its unit. SI unit of torque. SI unit of torque is Newton meter. Okay, you may note it as N plus M. Okay, Newton meter. Okay. The CG's unit of torque, CG's unit of torque is centimeter. So come to the point. Gravitational unit. In gravitational unit, force are measured. So we will measure the gravitational unit also. We will consider that gravitational unit. As it is mentioned here in your book. So, SI unit of moment is SI unit of moment which kgf meter. Okay, and CGS unit of moment which GF centimeter. Okay, its value is let's also understand that we know that I have already taught you 1 Newton meter is equal to 1 Newton is equal to 10 to the power 5 dynes. So 1 Newton meter is equal to 10 to the power 5 dyne. 10 to the power 5 dyne into 100 dyne into 100 centimeter. It means it will become 1 Newton meter is equal to 10 to the power 7 dyne centimeter. Okay. 1 kgf meter is equal to 9.8 Newton meter and 1 gf centimeter is equal to 980 dyne centimeter. 1 kg f meter is equal to 9.8 Newton meter. 1 gf centimeter is equal to 980 dyne centimeter. Okay, this is the units and some conversion you will need in solving numericals. Okay.